Hello everyone, I am Dr.VRAO-PHYSICAL. When we concerns with chemical reactions, we often heard the terminology catalyst, homogeneous catalyst, heterogeneous catalyst. Catalyst, homogeneous catalyst, and heterogeneous catalyst. Right? And catalysis, homogeneous catalysis and heterogeneous catalysis. Let us look into these concepts and its deeper insights. We know that catalyst is a foreign substance which accelerates the rate of reaction without participating in a chemical reaction. In fact, it accelerates the rate of reaction by decreasing the activation energy of the reaction. Right? Right. And catalysts are classified into homogeneous and heterogeneous catalysts. Usually catalysts classified into homogeneous if they are soluble in reaction medium, and they are classified as heterogeneous if they are insoluble in reaction medium. Right? Then after the reaction is over, products are formed, but we need to separate the catalysts from the reaction mixture or reaction products. Right? Homogeneous catalysts should be separated from the reaction mixture or reaction products, as this homogeneous catalyst is soluble in reaction medium. But it is somewhat difficult to separate the homogeneous catalyst from the reaction products. Right? So it is a negative feature for the homogeneous catalyst. But homogeneous catalysts or homogeneous catalytic reactions operates at low temperature and low pressure. So it is a positive feature for homogeneous catalysis. And homogeneous catalysis gives high selectivity, good selectivity. Right? So it is another positive feature for the homogeneous catalysis. Right? And the first effective homogeneous catalyst was the first effective homogeneous catalyst was square planar 16 electron D8 complex, that is chlorotris triphenyl phosphine rhodium 1. Right? This is called Wilkinson's catalyst. Right? Chlorotris triphenyl phosphine rhodium 1. Right? Chlorotris triphenyl phosphine, chlorotris triphenyl phosphine rhodium 1. Right? This is called Wilkinson's catalyst. Wilkinson's catalyst is homogeneous catalyst, and homogeneous catalyst enables us good selectivity, and it operates at low temperature and low pressure. Right? But it is somewhat difficult to separate homogeneous catalyst from reaction products. Right? And coming to the heterogeneous catalyst. Heterogeneous catalyst, it is easy to separate from the reaction products or reaction medium, because it is insoluble in reaction medium. Right? So it is it is easy to separate heterogeneous catalyst from reaction products. Right? It is a positive feature for heterogeneous catalyst, but it operates at high temperature and high pressure. So it is a negative feature in case of heterogeneous catalyst. Right? And it usually heterogeneous catalyst gives a mixture of products, that means it is it gives low selectivity, right. So, the examples for heterogeneous catalysts are nickel, platinum, palladium, nickel, platinum, palladium, right, vanadium pentoxide, chromium trioxide, Cr2O3, etc. These are the examples for heterogeneous catalysts, right. So, homogeneous catalysts have advantages over heterogeneous catalysts. That is why Wilkinson's catalyst is very familiar, right. And coming to the catalysis, catalysis is a process where one can accelerate the rate of reaction. Catalysis is a process in which where one can accelerate the rate of reaction. And catalysis is also classified into homogeneous catalysis and heterogeneous catalysis as per the classification of catalysts, right. And in case of homogeneous catalysis, the rate of homogeneous catalysis is directly proportional to the concentration of catalyst, right. Homogeneous catalysis directly proportional to the rate of homogeneous catalysis reactions, okay, directly proportional to the concentration of catalyst, right, directly proportional to the concentration of catalyst, right. Whereas heterogeneous catalysis is directly proportional to the surface area of the catalyst, right. Heterogeneous catalysis is directly the rate of heterogeneous catalysis is directly proportional to the surface area of the catalyst, right. And there are several examples for homogeneous catalysis. Of among that several examples, acid base catalysis and enzyme catalysis are very important, right. So, acid base catalysis and enzyme catalysis are examples for homogeneous catalysis, right. Acid base catalysis and enzyme catalysis. Enzyme catalysis are the most important examples for homogeneous catalysis, right. Okay. So, let us look into the enzyme catalysis, because we know that acid base catalysis, we are very familiar with acid base catalysis, but we somewhat we are not familiar with enzyme catalysis. So, let us look into the enzyme catalysis, right. Enzyme catalysis, for example, life is possible, actually our life is possible due to the coordination of several chemical reactions that takes place in living organisms. For example, digestion of food, right. I repeat, life is possible due to the coordination of various chemical reactions that takes place in living organisms or in our biology, body biology, right, our body biology. For example, digestion of food, absorption of appropriate molecules and ultimately gives production of ultimately gives energy, right. Actually these processes takes place with the help of biocatalysts called enzymes. These processes called these processes are catalyzed by biocatalysts called enzymes, right, enzymes. Enzymes. Actually digestion of a food or absorption of appropriate molecules and ultimately giving the ultimately produces energy. All these reactions involves a sequence of reactions, which are catalyzed by very mild agents, those are called enzymes. Okay, those are called enzymes. Okay, for example, starch is converted into, maltose. This is a enzyme catalytic reaction that takes place in our body biology. Okay, starch is converted into maltose, and this enzyme catalytic reaction is being catalyzed by an enzyme diastase, right, and then maltose is converted into, glucose. This is also enzyme catalytic reaction, and this reaction being catalyzed by enzyme maltase, right. Therefore, these are the enzymatic reactions that takes place in our body biology, right, and these are being catalyzed by enzymes diastase, maltase, right. Actually these are the sequence of steps that involves in producing energy, right. At first starch is converted into maltose, and then maltose is converted into glucose. So these are the sequence of steps that takes place in our body biology, and these sequence of steps are being catalyzed by certain enzymes, that is diastase and maltase, right. So these are the enzyme catalytic reactions, these are the examples for enzyme catalytic reactions that takes place in our body biology, right. So whatever the chemical reaction, okay, being a chemist, whatever the chemical reaction, we need to discuss their kinetics and rate of reactions. We need to discuss rate of reaction and kinetics of those reactions, right. The enzyme catalytic reactions actually enzyme catalytic reactions are very important, and the kinetics of enzyme catalytic reactions are much more important. Okay. So these enzyme the kinetics of these enzyme catalytic reactions are being studied by Michaelis-Menten mechanism. Okay. So Michaelis-Menten mechanism, that with the help of that concept, right, with the help of the Michaelis-Menten mechanism, we can study the kinetics of enzyme catalyzed reactions, right. So in the next video we shall look into the kinetics of enzyme catalytic reactions, right. Thank you.